What's in your hand?
My pencil.
A pen?
Yeah. Wow, really
That
got me there.
that plumber is really good.
Oh wait, it's not March
fall.
anymore. Holy Toledo, it's April.
Third.
April 3rd. Yep. So you guys remember the compound interest stuff you did with like you invest $10,000. Just turn around, Kale. Let's don't feed the troll. So if you invest $10,000 at 8.15% interest for 50 years, blah blah blah. So you remember you did a whole bunch of this. If you've been here, you've done a bunch of this. We're going to change it up a little bit today, and so I'll give you a moment to copy this down, but I'll show you kind of an example of what this is going to look like. So Mark invests $5,000 in an account that pays 8.25% interest compounded monthly. You really should start writing right now so that you're not that person who's like, wait, don't scroll. Wait. So just start copying right now. So Mark invests $5,000 in an account that pays 8.25% interest compounded monthly. How much? You did this last year because you took Algebra 2. Yes. How much will the account be worth after 38 years? I wasn't sure if I was going to go down this road with you, but I just thought if we're going to do this formula, let's see the formula from the other side as well. We're not going to solve for R, we're not going to solve for P, we're not going to solve for T. All that stuff involves a lot of algebra 2e kind of stuff. But I do want you to see the formula in its more fancy variety. It's more fancy outfit. So the difference is the word monthly, and that's a new guy for us. So the 8.25%, by the way, is an annual interest rate. So I'm gonna add that in here. So whenever you guys see your interest rates, assume that those are. So this is 8.25% per year. So that again is annual interest. So the difference this time is you get 8.25% still, but you get it at 12 different times during the year. But you don't obviously get 8.25% in January and then another 8.25% in February and so on and so forth, because then that would be 100% interest. That would be 8.25 times 12. And that's, of course, not what we're doing here. So what happens is you get your 8.25% and you basically break it into, do you guys have calculators? Would you grab them real quick? We're gonna use the heck out of them today. So grab that thing and get ready to roll. We're still doing compound interest. I'm sorry, I didn't write that down. I should. We'll call it more with compound interest. That's, I guess, what we can call our notes for today. So here's what I wanted to tell you. If you take 8.25% interest over the course of a year, by the way, this is a very easy lesson today. I just want to show you kind of behind the scenes what's going on. So if I get over the course of a year, I get 8.25% every year. What I want to do is I want to break that into 12 pieces because I get a 12th of it in January and then a 12th of it in February. And so using your calculator, take 8.25% and divide it by 12. And you can leave it as just leave it as 8.25. Yes, and we should all agree. Yeah, please don't put in any zeros. Just literally take the number that's in the red oval up there and just take 8.25 divided by 12. And we should all agree on the following number, 0.6875. Now, what I wanted to tell you is that you're getting that much interest in January. It compounds then again with the same 0.6875 in February, and then it compounds again in March with the same 0.6875. My question to you is, does it make a difference?
If you do it monthly.
Does it matter if you do it monthly or just once a year? Big time, yes.
Yeah.
And so the thing is this, it's okay to answer that question incorrectly, because like, why would you know? But if you think about it, if you're constantly compounding into yourself more often, then you're benefiting from compounding more often than once a year. And I understand the logic of saying, well, I'm still getting 8.25%. Like, what's the difference? Well, it makes a difference as to how it's broken down. The more frequently it compounds, the more beneficial it is to you as an investor. Follow?
No.
So again, I am getting 8.25. It would be like saying if I got 12 cookies, instead of getting all 12 cookies at once at the end of the year, I get one cookie in January, one cookie in February. And that's not a good analogy because it's not very mathy. But the point is, I'm getting exactly, let me write this and see if this makes sense to you. This is exactly 1/12 of my 8.25%. Do you buy that?
Yeah.
So you'll have to trust me on this one that it does serve a beneficial purpose. And it's not, I said big time, that was a lie. It's not actually that big of a difference. But you will earn more money if your money compounds more frequently as opposed to if it doesn't. It's just every time you add in a little bit of interest, it compounds again. So you're basically, boy, I don't know how to try to explain this to you. Every time you add in 1/12 and then recompound and recompound, at the end, let's say at the end of 1 year, here, I'll just tell you right now. If I just did one compounding of 8.25%, at the end of 1 year, I would get $412.50 in interest. If I were to take that 8.25% and get 1/12 of it each month and have it recompound every month, this $412.50 would probably be like $417. It is better. You get more. So rather than ask, do you understand that? Let me ask you, do you believe me? Good. So there's a formula for this, and this is what it looks like. So we have a new formula for the day, and I'm going to erase some of my handwriting here. And it looks like this. So this is our new formula that we're going to add to our repertoire. So far, it looks the same, right? In the previous version of the formula, we would have just put R. We're going to put R over N. And then the exponent, you'll remember, used to just be T. Our new exponent is N times T. And I'm going to wait until I know that each of you has written that down. Because, you don't want to be the kid that's like, what was that formula again? It's annoying, right? So everything is familiar. Like, you know what A is. A is the final amount. You know what P is. P is what you started with. You know what R is. It's the interest rate. T is time in years. What do you think N is in this case?
Like the smaller.
What would you say if I told you in this problem, yes, N is 12. N is how many times it compounds per year. So we have a new player today. We have a new character, and that is N. So if it's monthly compounding, since there's, 12 months in a year, then N is going to be 12. What if it said quarterly? What would N be?
Would it be?
Be 4 times a year.
Yeah.
There's 4 quarters in a year. There's the January through March quarter. Then there's you get the idea. What if it said semi-annually? What would that be? Twice. What if it said daily? 365. Good. So basically, we're using the formula again, only this time we have to incorporate n into it to take into consideration the fact that our interest rate is being broken up, but then we account for that up in the exponent. So let's take a look at this problem and let's plug in some numbers and see what we get. So here we go. We're going to say A equals, and what are we going to put in place of P?
5,000.
Nice. And then we're going to put 1 plus, and what are we going to put for R?
Would it be 0.6875 or 8?
It's, by the way, that 0.6875 has nothing to do with this anymore. It's 0.0825.
So how do you,
I'm not worried about that yet. I want you to write this down before we start.
Over 38? Over 12.
Over 12. Because remember, n is the number of times per year. And now my exponent is going to be 456. Now, you might wonder where I got that, and I'm going to draw a little green box up here, and I want to draw your attention to that little green box. Do you see it up there?
yeah.
That says to do n times t. In this problem, what's n? 12. What's t?
38.
And what's 12 times 38?
400.
Jackpot.
So months by years.
N times t in this case. It's not always going to be months times years. N is 12 because it's compounded monthly, and monthly means there's 12 months in a year. And so if you go up into this exponent right here and do 12 months times 38 years, if you do something once a month for 38 years, you do it 456 times. Because 12 times 38 is 456. Y'all better? So let's get our calculators rocking and rolling. And you've done this before. So the whole act of like how to do exponents and stuff should still be familiar to you because we did this just without the new n in our formula. So here we go.
Would you just divide it by 12?
You just so here's what my calculators, this is what I'm going to type in my calculator. I'm going to write this in white for you. I'm going to write 5,000 parentheses, and then I'm going to type 1 plus 0.0825. I'm going to divide it by 12. I'm going to close my parentheses. I'm going to hit my exponent button and then type in 456. And then I'm going to hit enter. And that is the end of that. I haven't actually had time to type it in yet because I was writing it on the screen.
Yep. And 72 cents.
Yep, $113,716.73.
Oh, my bad again.
Because we round up.
It'll get to you. Okay.
Good so far? So far, so good. Okay, let's practice one more time. We're going to do, I'll write the answer up here so that you guys can make this official. So it comes out to be $113,716.70 rounded up 3 cents.
Should we put the line underneath the 73?
Doesn't,
okay.
I don't.
Because I've never seen you do that, but you.
Sometimes I do, sometimes I don't.
Okay.
Hit or miss. You know.
I do another one.
Let's do another word problem, and then we'll get on the IXL after this. So. Zoom. Julio deposits $27.50 into an account with 6.05% interest compounded daily. How much will be in the account after 50 years? 50 So I will say that there's a part, I mean, the calculator does the heavy lifting, obviously, but I would appreciate it if you would always show how you're doing it on paper. Because then when people ask questions like, hey, how did I get this? Then I can always look at the work because it's usually something silly that's in the work. So here it goes. I'm going to write A equals. And what am I going to put first? Nice. And then in parentheses, I'm going to put 1 plus what?
0.06.
Nice work. 0.0605 over what? 365. And if you're already on the calculator, you're still not hearing what I'm saying. This should be on paper before we go to type it in. Lay it out first. My exponent's going to be really, really big because n is 365 times per year and time is 50 years. If you do something every day for 50 years, that is 18,250. The interest rate. So since this was a 6.05% interest rate, we converted it over to a decimal 0.0605. Good? Okay. So I'm going to type in 2750 parentheses 1 plus 0.0605 divided by 365, close parentheses, to the power of 18,250. You should have all gotten $56,619.32. I have a feeling that you probably forgot to move your decimal all the way over, Brandon. Maybe that's why.
I have a 0.0605.
Divided by 365?
Yep.
And then you closed your parentheses?
Oh, it's because I didn't do the little extra.
I do know that thing. Yeah. Mm-hmm.
So what do you think about decimal point? How do you use decimal point? Because you have the percentage in it.
I take the number 6.05 and I move it always 2 places to the left. And since I don't have enough decimal places, I always add zeros as necessary. And that is how you get the decimal. Always 2 places to the left. Daily, because there's 365 days in a year. If you really want to be uptight about this, by the way, a lot of people, and I do this in my other class, a lot of people use 365.25. I'm not going to make you do that. Do you know why that would be? What happens every 4 years, you get a leap year, and every 4 years, the year actually has 366 days. February 29th exists every 4 years. Good. And that's exactly 1/4 of the years, which is 0.25. So,
if you're born on a leap day,
A birthday?
Yeah.
So
Yes, you never die.
the skill, hey guys, just hold on, please. The skill on IXL that I want you to do is, I'm going to write it up here on the board, is skill QSF. Got it?
What's that mean?
That's the skill. You're going to go to IXL and search for that skill, and I'd like you to go work that out. Got it?
Mr.
Yes.